Hello friends, you're watching Gate Helpline, and in this video we'll see question number 55 from Gate 2021 CS set number 1. So friends, question number 55 is from computer architecture. So friends, the question states, consider the following instruction sequence where register R1, R2 and R3 are general purpose and memory of X denotes the content at the memory location X. And below we are given with the instructions. Below the instructions, assume that the content of the memory location 5000 is 10 and the content at the register R3 3000. The content of each of the memory location from 3000 to 3010 is 50. The instruction sequence starts from the memory location 1000. All the numbers are in the decimal format. Assume that the memory is byte addressable. After the execution of the program, the content of memory location 3010 is dash. So friends, this is a very easy question. Just you need to focus on whatever is given in the question and what this instructions and their semantics will behave. So now we'll go to the dashboard area where we have already copied the question for you and we'll try to explain this question. So friends, this video is going to be a bit lengthy because we'll see each and every aspect of this question. So friends, we'll start with the question and we'll see what are the things which are given to us, and those will be helpful in understanding this program. So friends, the question starts with, consider the following sequence where register R1, R2, R3 are general purpose register. So friends, here we have these three registers, that is R1, R2 and R3. And then memory of X. This is something which denotes the content at the memory location X. So whenever you see memory of X, that simply means the content at the memory location X. Okay. So friends, I will just bold it for you. Assume that the content of the memory location 5000 is 10. So here we are given. So 5000 is the memory location similar to X, and the content which is present there is 10. Okay. And the content of the register R3 is 3000. And what is kept at R3? R3 we have kept a location. Just keep this in mind. R3 we have kept a location and the value of that content which is present at R3 is 3000. The content of each of the memory location from 3000 to 3010 is 50. And friends, the next thing is the content of memory location from 3000 to 3050 is 50. So on all the location 3000, 3001, 3002 till 3010, the content which is present there is 50. Okay. The instruction sequence starts from the memory location 1000. All the numbers are in decimal format. This is fine. After the execution of the program, the content at memory location 3010 is dash. So friends, initially the content present at the location 3010 is 50. And we need to tell after the execution of this program, what is the content at this particular location. Okay. So friends, now this is the instructions which are given to us with semantics and the instruction size. So what we have is, we have these two tables as well. Okay. So the first table is having the location, that is the address location, and the second column we have is the value. Okay. So in question we are given with the 5000 location is having content 10. Okay. That is this. And from 3000 to 3010 we have a content of 50 at all these addresses. So this is what we have written here. Next thing is, we have three registers, that is R1, R2 and R3. R1, R2 we will use in the program, but R3 is having an initial value of 3000 which is given here. Okay. So this is something which we have kept here just for our own understanding. Okay. Now we will go to the program. So friends, the first instruction is R1, we are keeping the memory location of 5000. Okay. So here we will be copying the content at memory location 5000. Okay. So what is the content at memory location 5000? That is 10, right? So the content of memory location 5000, that is 10, will be copied to or moved to R1. Okay. So this is R1. R1 is having value of 10 now. Okay. Now second instruction, memory of R3, that is content of memory location R3 will be moved to R2. Okay. So what we have at R3? R3 we have 3000. Okay. So this is the memory location. Okay. At 3000 memory location, what is the content we have? The content we have is 50 there. Okay. So friends, instead of writing the location here, what we are writing the register name. That is similar to the above instruction only. Instead of 5000, we have directly written the register name, that is R3. And what we have in R3? R3 we have 3000. So if we write memory of 3000 here, the answer will be the content. And the content we have kept at 3000 is 50. Okay, that is initial value. And this content we are copying to R2. Okay, so now R2 will be having value of 50. Correct? Now R1 plus R2, that is the content of R1 plus R2, will be summed and stored in R2. So 10 plus 50 will become 60 now. Okay. So in R2, what we have now? We have 60 now. Now in the next instruction, R2, the value of the content of R2 is now moved to memory location of R3. Okay. So what is the memory location of R3 now? Memory location of R3 was this thing only, that is the 3000. So this value we have again moved to the location of R3, memory location of R3. So here instead of 50, now it will be converted to 60. Okay. So the new value which is present at memory location 3000 is 60. In the next instruction, we have R3 plus 1. Okay. So what we have in R3? R3 we have this 3000, right? So we are incrementing the value of R3. So now R3 will become, instead of 3000, it will become 3001. That means it is now pointing to 3001 location. Okay. In next, we have R1 minus 1. Okay. That means we are decrementing the value of R1. So now the updated value of this R1 will become 9, right? This value is decremented and its value is now 9. Now branch if not 0 to the given absolute address. Now what it is doing? It is doing a branch if it is non-zero. Okay. So friends, we have started with memory location 1000, that is 1000, and we are branching to 1004. So this instruction is at location 1000 and this instruction will be plus 4 to it because the instruction size we have of 4 bytes. So this will be 1004. That simply means from here we are branching to second instruction. Okay. So here what we can write is we are directly branching to this point. Okay. So now we have these values here and now we will be going to this point, that is memory address, that is the content of R3. Okay. So what content of R3 we have? The content of R3 we have at memory location 3001. So at 3001 we have another 50. Okay. This 50. So now this 50 is moved to R2. Okay. So now the updated value of R2 will be again 50. Fine. That is the second iteration what we are following. Now in the third instruction we have R1 plus R2. Now again R1 plus R2 will become 59 and then this value of 59 is moved to R2 and then the value of R2 is now moved to memory location at R3. So what is the memory location at R3 we have? That is this 3001's value. So this value of 50 will now become 59 because that is 50 plus 9. This will become 59. And then in the next instruction, it will be the value of R3 is increased. So now this value of R3 will be increased to 3002. Okay. And in the next instruction, we are again decrementing the value of R1. So this value of R1 will now become 8. Okay. So now again we are checking for the branch. So if non-zero to the given absolute address. So the value of R1 is again non-zero. That is this value of R1. Okay. This is again non-zero. So again we will be branching to 1004. So that is the second instruction. So in this instruction again the content of memory address R3. So now at R3 we have 3002. That is this time we are checking for this value in R3. Now this 50 is now moved to R2. So R2 again will be having 50 here, which was earlier 59, right? So now we have 50 here. In the next instruction, we have R2, the value of R2 plus R1. Okay, so R1 we have 58 and R2 we have 50. So now R1 plus R2 will be moved to R2. Okay, so now we will have the updated value, that is 58 in R2. Next, the value of R2 is now moved to the memory address of R3. So the memory address of R3, so it will be having a content of 58 now. Okay, then again this particular address at R3 is updated. So now it will become 3003. Okay, and then again we are decrementing R1. Okay, so now R1 will become 7. Fine. And then again we are checking for the branch. So if we check for the branch, again the value of R1 is non-zero. That simply means again we will be coming to instruction 2. So friends, this particular loop will be keep on running until when we are reached to R1 equals to 0. Then only this loop will end. So at least for R1 equals to 1, this iteration will go on. So let's see. Now this one will run for R1 equals to 7, 6, 5, 4, 3, 2, 1. Right? So here the value of R1 will be equals to 1 and the loop will go on. And if we see, there is one more iteration which is keep on going, that is decreasing this value. So even if you see this, that is we have started with 60, 59, 58, 57, 56, 55, 54, 53, 52, 51 and then 50. So even if we see this way, the value of 3010 will remain as 50 only, because the value of R1 we are keep on decreasing. So friends, as per this explanation, answer to this question is the value of R3 will be 3010 at the end of this cycle or this loop, and the content present at the memory location 3010 will be 50 only. So friends, now quickly we will go and see the question. So this one is a numerical answer type question. So better we will go and check the answer keys. So friends, in official answer keys, you will see for question number 55, the answer is 50. And this question carries 2 marks. So friends, this is a fairly easy question and this was a bit lengthy question. So in exam, you need to keep calm and understand this question. And you need to spend some time on this type of questions as well. And friends, these type of questions are repetitively asked in GATE examination. So friends, and do some practice on these type of questions as well, where you are given with the instruction set, and as per the semantics, you need to run the program with the help of few registers and memory addresses. So friends, if you have any doubt or any question, you can ask us in the comment section. So friends, thanks for watching. Please like and subscribe and see you in another video.